All right, so I'm assuming everyone was able to download the GitHub repo, move that spatial partial from the GitHub repo folder into the current project's code folder. So if you were able to do that successfully in our studio, again, you can come in here on the right side, Files tab, click on that R blue button to take you to the home folder of the project, if you were not there yet, and then go under Code, and then click on that NASS spatial partial, so it pops up and we can start working on it. Okay, so assuming everyone was able to do that, so there are some packages that we're going to have to install to do some of the things that we're going to be doing on the second part. So what I want to ask you to do is I left all the install.packages functions for you. So please uncomment the first one and then run just that. So don't run the entire chunk. If you have your cursor anywhere in this line here, you can just do command return or control enter, and that will run just that. So please just go one by one installing them. And it shouldn't take a lot of time, but I will just wait for you all to go through these. So we have 5 packages that we're installing here. Make sure once you install a given package, you also comment off that install.packages, because again, we just install once. If anyone has any issues installing a given package, please let me know. I'm going to do that myself as well.
Yeah. Yes. Control enter. Yeah.
All right, so I just did that myself just to make sure, you know, that I was giving you enough time, and I was able to install all of them right now. Anyone still need some more time to install?
Yeah, we still are working on installing out there.
Okay, sounds good. Let me know when you guys are good to go.
Yes, sir. Well, it's a little over halfway done, so we should be getting close.
Okay, awesome. So, you know, just
while loading some packages, like it says it requires some other package known as Veritas Lite. Do we need to install those packages as well?
so did that say that you need a Veritas Lite as well on the when you install Veritas?
Yes.
Yeah, so if you yeah, for me that didn't show up, but maybe that's because I already had Veritas Lite. So if that is the case, I mean, were you able to install Veritas, or did it give an error? I guess one way that you can check if the installation worked or not is if you try to load the package using the library function. If you try to load it and it says, if it says loading required package for this light, then you got it. If it says like package for this doesn't exist, then you weren't able to install.
We're good here in Tifton.
Awesome, thanks guys.
And for GZ Anime, it says we need some other packages for different outputs, so it should be fine for now.
Yeah, I think so. I think those are just some warnings, but I think you were able to do all that.
Thank you.
Yeah. Okay, so I think everyone was able to do it. So if you commented off all of the install packages, so please do that. If you haven't, just comment off so R doesn't run them again. So now if you just play this first chunk, you will just run the library functions, which we need to do the geospatial side of things. I know that in the past, some people have, so here I just got a message saying linking to geos, GDAL, proj, and so on. This is something that package SF is doing. And these are libraries that are not part of ART necessarily, but are part of your computer. So when we get to the SF, using SF package, if you have issues, let me know, because then that probably means you need to install some more things on your computer. But if you have done any GIS in the past, so if you use ArcGIS or QGIS or something else, you probably already have these computer level libraries installed. So let's just keep going. If you have issues, let me know. Okay, so even if you still have your data here, that's completely fine from what we just did before. But assuming that you didn't have your SOIW there, we would read in again the SOIW that we just exported on the previous script. So to do that, we would use the read_CSV function. We would open and close quotation marks. We would get outside of the code folder, go inside data folder, and then bring in the soybeans NASS processed version and import that as SOIW, right? Maybe you already had SOIW on the top, so you wouldn't have to do this, but that's just to show you how in one script we develop, we did wrangle the data. Now, if we were to bring the soy, just the raw soy again, we would really have to do all the wrangling again in this script. So to avoid doing that, we exported the process version and we bring in the process version on this script. I just wanted to show you that. Okay, so a question for you all to think about. So the data that we downloaded from NASS was not geospatial, right? It was not a shapefile. It was not a GeoJSON, whatever it is. That was not it. It was just a data frame, right? It was an Excel file, I think, or a CSV file. Now, how can we turn that into a geospatial data frame? So if you think of it, there is a shapefile for each county in any state in the US. And there is, if we didn't have a package that to help us to get that shapefile or the vector data for each county, you will probably go on the website of the state of Georgia, and they probably somewhere in their website have, a shapefile with that geospatial data for counties. However, there is a very cool package in R that actually gives you the vector data or the shapefiles for any state or counties for any state in the US. So that's what we're going to do here is if you come on the next chunk, I left you the object name that's going to be Georgia County, so GACO for that. We use the assign symbol, and there is a function called US_states that is coming from the US boundaries package. So here it has an argument called states. We're just gonna say equals Georgia. Or you know what? Actually, I told you the wrong function. So this would return the vector of the Georgia state, which is actually not what we want. We want the counties. So instead of US state is US_counties. So this is what you want to have. Okay, so if you run this and it runs successfully, you should be now seeing the Georgia County object on your right side on the environment. Let's just check the class of this object. So if we get the class of it, remember, this is how R is interpreting this data frame. It is a data frame, but is also an SF object. So if you remember from our lecture, there are a few different ways that R handles vector data, like vector in the sense of geospatial data. One of them is treating them as SF.
Hey, did you put that? Yeah. Dr. Mesos, we got a problem down here. It's saying that there is no package called US boundaries data.
I installed all the packages. I don't know why it's.
Okay, so that's, I think that happens because for some reason the US boundaries requires another package, and for some reason it doesn't automatically install it. So if that was the case, let's just do another install.packages. And then it's, well, I don't remember now. I think it's US boundaries. Let me see, USA. Yeah, so data uppercase D, right? So if you also had the issue of saying that you don't have this package, just go ahead and try to install it like this. And I think that should suffice. Maybe you're gonna have to load again USA boundaries after installing that, and then try again using the US counties function. And
So he got an error saying that, that this version is not available, but it might be available elsewhere. I would get that same message.
okay,
I solved that problem. Cause while loading that install.packages USA boundaries, if you look at the consoles, you will get the complete like code which to run. Like it has repos is equals to HTTPs, Reponsky something. Like you have to add something after USA boundaries data. Probably that's
I see. So for anyone who's having issues with USA boundaries, when you install USA boundaries, yeah, double check your console to see if you get any messages there, because that message may contain the code that you need to run to install the USA boundaries data.
I think always sure.
Yeah, it says the same thing in console as well. Like this US boundary data is not available for this version of R.
Okay. Well,
But I
that's
think that command from console and pasting it on the main.
So I copy all of
Yeah,
the
up to source.
and I paste it here.
Yeah.
And if you run
Right
that,
here, or maybe
You just cancel that one and install.
let me do a quick search here. I know that USA boundaries. I know they have a GitHub repo that may have this code available, so I can show here my screen.
You can.
Okay, so maybe this is that. Okay, so there's gonna be a, let me just copy this and paste on my side so we can all do that. So if you are having issues with the USA boundaries data, we're gonna have to install the USA boundaries data package from the GitHub repo of their GitHub repo. So what happens is to do that, to install a package that's not coming from R, but it's coming from GitHub, we have to install another package first, which is the install or the package called remotes that give us access to GitHub and installing packages that way. So if you're having issues with USA boundaries, go ahead and install the packages remotes like this. So we have the packages, the package remotes, and then we can download the USA boundaries directly from GitHub. So if you install the remotes, I think that should be, if it gives you something like this saying our studio can restart, you can just say no. So the remotes install very easily. I'm just going to comment that off. And now you can, so if you remember, for you to call a function from a package, you say package name. So in this case, remotes, : and then it has a function called install _ GitHub. So here we're going to say where in GitHub is the package that we want to install. So it's, you can open and close quotation marks. It's called R open sci for open science. So R open sci, all lowercase, / USA uppercase. So USNA uppercase. And then boundaries, all lowercase, boundaries, and then data with capital D. So if we do this, that should install the USA boundaries data directly from GitHub. And for me, it gave me a message because I already have the package installed. But for you, I think it should work.
Hang on, Dr. Bastos, can you leave your screen right there where we can kind of watch?
Sorry, can you repeat that?
Can you just leave your screen there where we can
Oh, yeah.
see the code?
Yeah, absolutely. Yeah, and the only thing I would say is just make sure that your case, I mean, R is case sensitive, right? So just make sure that wherever there is a uppercase, you make sure you do uppercase. So USA, all uppercase, boundaries, all lowercase, and then data with capital D only.
Dr. Bastos, it's showing that it's done with US boundaries data, but when I'm running code again, it's still giving the same error.
Did you try to load the USA boundaries again with the library function?
No.
Yeah, maybe try that and then let's see if that works.
But
It worked?
Yeah.
Awesome. Okay, how are you all doing, Tifton?
Mine is still downloading, I believe, but I'm hoping it's about to be through.
Miller is still getting the code in, so we're still just a few minutes.
Well, it's now saying that USA boundaries is being used.
Yeah, you can if it gives you like a no or yes, you can just say no, and I think it should install.
install so go down, what is showing? Run this code. Downloading, go down.
For those in Griffin, is it working all right? Cool. Sarah, Shakar, is that working all right?
Yes, it's okay.
Cool. Good deal. Matt, did that work for you?
Yeah, I'm good.
Awesome. Okay, so I think let's just give another minute here just for Tifton and Athens to catch up.
Good.
Mine's saying that USA boundaries is in use and it won't install.
Okay, what options does it give you?
I don't know. There is a not. I don't know.
This should be the right install.
How's Athens doing? Was everyone able to get it through?
Come back here and talk to Austin about what he did.
Amrinder, how are you all doing in Athens?
I'm done, everybody's done? Yeah, here we are good.
Okay, awesome. Okay, were you guys in Tifton able to figure out?
No, give us just a second. Though one of them is still showing that it's like the package is in use, but we're just trying to delete everything and restart. I'm sorry.
No, that's all right. Yeah, sorry. Some of these packages I've installed a while ago, so I don't have a good feeling for all the trouble that may happen when installing for the first time.
Well, see, whenever, because mine stopped on my MacBook and then it prompted me to install a different package. Like it gave me the whole code to install.
And that worked.
Yeah, mine worked, but for some reason their code is not working on theirs. So we're having to manually enter it like how you did.
Okay. But yeah, so
Mine's building.
Yeah, we've got one that's working and we're working on the other.
okay. Well, I think I'm gonna continue. If for some reason this still doesn't work, let me know and after class we can connect and I'll help you out.
It's working now, I think.
Perfect.
It's thinking.
Okay. Awesome. Well, I'm gonna keep going here just so everyone else is also following. But yeah, if the issue still persists, let me know and we'll troubleshoot afterwards. All right, everyone. So let's continue here. Let me just delete all this that I had in there. So if you again were able to if you got to the point where you were able to run the US counties function properly, right? So we talked about the classes and I just want to print it just so you see what is going on here. So if we print it, you see that, so it says that it is a simple feature collection, right? So that's what SF stands for, simple feature. It's telling us it has 159 features. So that's the number of rows and 15 fields. That's the number of columns. It says that the geometry type is multi-polygon, meaning that we have many polygons inside of this object. And then it gives us some information about like the bounding box. So what is the bounding box? If you think of a map of the state of Georgia, what would be the box that would encompass all the states? That's this bounding box. And very important is telling us the geodetic CRS, so the coordinate reference system, that is WGS 84. If you recall this from class, this is going to become important here because we're going to be either using WGS 84 or NAD 83 UTM. So just for you to keep in mind, this is WGS 84, so it is in degrees. It's not meters, as we spoke in class. And then it gives us some information about the data here and what's in it. So I want to make a quick plot just so we can visualize what this is, right? So if you come here on the quick plot heading or comment, we're going to start with ggplot. We're going to leave empty at this level, just add a plus, and we're going to call it geom_sf. So this is a special geom that works in ggplot to plot SF objects, which again are vector geospatial data sets. So we have to say data equals, so Georgia County, GA_CO, and that's all. So if we run this, it should produce a map of Georgia and Georgia counties boundaries for us. Okay. So basically, this object here, this Georgia County object that we just created, is a geospatial vector type of data where we have the geospatial information as one column, and we have other information, not necessarily geospatial, as other columns. I just want to show you here, if I do a view of this object, just so you see. So this is how it looks like. It looks just like a data frame, right? So with different columns, different values, and so on. But then one of the columns is called geometry. And this is where the geospatial data is stored. And this is why it's such a powerful type of object. And that's why we're using SF objects, is because it still is a data frame, but one of the columns is where the geospatial data is stored. Other object types do not work. I mean, other spatial object types do not work like that. And it's more complicated the way that they relate the geospatial data with the attribute table or the extra data that you have that is not necessarily geospatial. Okay, So we have this object here, we have the geometry there, which is what we needed, is that geospatial data of the counties. And now imagine that we want to bring in another column that is coming from the soybeans process NASS, that would be production. Because we already have the polygons for the counties. Now we just need to have a column that says production in that county, and then we can plot, if we can make a map of the counties and the production in that county. But that's kind of the goal of what we're going to do next. So if you come here to the next chunk, I already left you some code. So we're going to do some data wrangling here. So before we merge the Georgia County object, which has, again, the geospatial data as part of it, with the soybeans NASS data, which again does not have geospatial data yet, but it has a column called county, right? So we can use that column called county to merge these two pieces together. That's what we're going to do here. Okay, so what I left the code here for you, but I just want to show you why we're doing what we're doing. So we're starting with soy W, right? So if I print here again, soy W is that almost 6,000 data rows that we were working up until this point. I am removing county values. So again, using a filter, using the different than Boolean operator, and removing any entries that are either other counties or other combined counties. Why am I doing this? It's basically because if there is data, but it is assigned with a county that we don't even know what county that is, we're not going to be able to show that on a county map, right? We just don't know what county that is. So that's why I'm filtering the data rows that have the county values are either other counties or other combined counties. I'm just going to run up until this point here and print it to you. So this is very similar to what we already had. But now one thing that I want to show you is a very cool trick here is if you look at the county name, so county is lowercase, the column heading is lowercase, but the values under that column are all uppercase. And if I, so, and again, this is the soy W data set, right? However, if I look at the geospatial data set, the Georgia County one, let me just do a view again so we can see. So view Georgia County. Oops. It has a column called name, so that is one difference. But look at how the county names are here. So it's just the first letter that's uppercase. So this difference, this mismatch has to be addressed because we're going to have to use this column that has county names as our key to merge the production data with the geospatial data. So to do that, on the code I left you here, that's kind of what we're doing with this next piece of code, where I'm basically overriding the county on the soybean data set. I'm overriding the county column using this function string to title. So it's using a title case, which is basically just the first letter of the word capitalized and everything else lowercase. That's what we're doing here. This is a very useful function if you need to change the case of a lot of values in a column. So if you just go ahead and run it and print it, now we're going to see that we still have that county column. Again, this is the soybean W data set. There's not the geospatial yet. But now the county names are just with the first letter uppercase, which is what we need to merge the soybean and the county geospatial data. All right, so we also need to do a little bit of so we just did a little bit of wrangling on the soybean W data to make it able to match with the Georgia County data, but we also need to do a little bit of wrangling on the Georgia County itself. So if you go to the next chunk, I'm just going to come here, and so we're starting with the Georgia County. We use a pipe, hit return, and we're just going to basically, the only wrangling we're doing is just selecting the columns, because right now Georgia County has a whole bunch of columns. We really only need two. So let's do the dplyr : select function. The two that we need are, so if I print, well, let's just see the view again. I think that's easier to. So we really only need this column called name and a column with a geometry. So with the geospatial data. So we would say select name and geometry, right? And if we print it now, we only have those two columns. Another small thing I want to show you here is, so right now, both the soybeans and the Georgia County data have a column that have county names in them, and that's great. But at this point, the name of the column is different. So on the geospatial data here, the name of the column is called name. And on the soybean data, the name of the column is called county. Those names should match. They should be the same for that when we merge both data frames. So the only thing I want to do here, again, coming down to the Georgia County W, is say county equals name. So this is basically the select function lets you select a column, but if you want to rename the column, it also allows you to do that by just saying new name equals old name and selects that old name as well. So if we run this and we print it, now our Georgia County data, which is again the geospatial, has a county column and has a geometry column. So that's exactly what we needed. Okay, so we wrangled the soybean W data, we wrangled the Georgia County data. Now let's merge them into one object. So if you come here in the next chunk, that's the soy_sp. We're going to start off with the Georgia County W. So we're starting with the geospatial one, adding a pipe, hit return, and we're going to use a function called left join. And inside of this function, we give the data set that we want to join to the first one. So the first one is the Georgia County, so the geospatial. We want to merge with that the soy_w_all, because that's the wrangled version that we just did above. So if we do this, it's going to tell us that is joining by county. Let's just print it. We have 4,451 data rows now. If you think of it, Georgia County W, if I just print that by itself, that had 159 rows. Soy W all had 4,481, and now Soy SP has 5,451. So it has a few less rows for some reason. I guess we're not going to get into that right now. But the main point is, if we now view the soy SP, so it becomes apparent what happened.
Dr. Bastos, like in fields, you have 4 fields and I have 5 fields. Features are same.
Say that again.
In the soy SP, I have 5 fields. You have 4 fields.
Okay.
In this here, you see the 4 fields. I have 5. Don't know from where extract them.
So here are the ones I have. So I have county name, I have year, production in bushels, production million bushels, and geometry. Oh, I think that is 5 actually, even though it's just saying. Yeah, so these are the ones I have. Do you also have those?
Yes. Yes.
Okay. So now look what happened. It basically looked at the soybean data. If it looked at the county column and it matched that county column with the county column on the Georgia County data, and then brought both data sets together, right? So now we have county year, production, and the geometry of the county all together. So now we really have the data set that we needed to continue our exercise. So we basically transformed the NASS data into a geospatial data by connecting it using county names to the county shape files or vector files. So this is something very cool. Like, if you think of it, any data set that you collect that perhaps has some, like the data itself is not geospatial, it didn't use a GPS to do it. But let's say if you did a study in, I don't know, Tifton or maybe Watkinsville or whatever it was, and you know that you did in that city, you can go and get the coordinates on Google Maps, for example, for that place and bring in here and then connect that perhaps, with the county that was in, if you want to show a map of counties with, counties that you did a study colored differently. And you really don't even need to create, if you think of it, the county shape files. That would be ridiculous. No one would do it because it's just a lot of work. you can just use a package that already has those vector files or shape files and just merge what you did with that county information. So this is a pretty cool trick to do, especially on presentations and publications and things like that. Okay, so the first thing I want to do here, now that we have a data set with the data we wanted, production million bushels, with the geospatial data as well. Let's do a plot where I want to plot. Oh, someone has a question? Nope. Okay. Let's make up a static plot, meaning that, you know, it's just a regular plot or map where I want to show the 2021 production by county as a map. So come to this next chunk here. Let's just develop this. So, you know, the first thing we're going to do is add the pipe. If you look at Soy SP, it has 5,000 and some rows. So it has data for all counties, all years. If I just want to show for 2021, you should be ringing in your head that we're going to use filter, and we're going to say year equals 2021. Right? So this filters to only contain data from 2021, which ends up being only 19 rows. What that means is that only 19 counties in 2021 reported production of soybeans. So if we add a pipe, hit return, and connect that on a ggplot, we can just leave the ggplot level open like that, add a plus at the end of it, hit return. Let's use a geom SF, right? So again, every time we're working with SF objects, which are the ones that have geospatial data, we have to show them as geom SF. So here I want to say, well, let's do this. Because I do want to have the county color or fill changing according to the production level, let's do AES fill equals prod underscore million bushels. And let's just run that to see what happens. So this is what shows up on my side. It's kind of cool, right? So the counties that did report production in 2021 are here, and they're being colored according to that production. However, I really wish I could see the entire map of Georgia with all counties, and then only having the ones colored, the ones that have data. So right now we don't have all counties, right? To overcome that, we can basically come back on that ggplot plus, hit return again. Now let's just say geom underscore SF. And let's say data equals Georgia County W. So if you remember, Georgia County W has all the counties of the state. And make sure you add a plus at the end so it connects with the next geom SF as well. So if we do this, then it's really doing what we wanted. So it is coming here, plotting Georgia County, all counties, and then the next layer basically only adding the counties that reported production in that year. Okay, so pretty cool, right? So we can see production in space now. We can not just go by county names, but actually put them in space, which I think is pretty cool. Okay, so the next thing I want to have here is to make the plot above publication ready. So let's talk about that again, right? So I left you some code here.
Hey, Dr. Bastos, I have a quick question.
Yeah.
I'm looking at my code compared to yours, and it looks like I'm doing the exact same thing, but I'm not getting the blue color outline of each county.
Okay, so that happened at the last geom-SF that we used. So we had to use the AES function and say fill equals production million bushels. And make sure that this is inside of the AES function. That's what makes it like give different values to different counties.
I believe I got that. Geom SF parentheses AES parentheses field equals prod underscore MIBU parentheses.
Have you add plus? Because I face the same problem.
Yeah, did you add?
I got both. I got.
Did you run?
Yeah, I didn't.
But did you run the Java file? Oh, FIL.
What's that mean?
You need one more L.
I found, got it.
Okay, cool.
And spelling lessons didn't apply down here, so.
Say that again.
Said the spelling lessons didn't make it all the way down here.
Yeah. All right. Okay, so so let's go to the next chunk. To make this publication ready, I already left you pretty much what we did above. The only difference here is that I'm changing the size of the width of the lines. So if you were just to run what I have here, you know, it just look a little bit like finer or thinner, the outline of the counties. That's the only difference until now. Okay, so I already left you here's what I want to do to make this publication ready. So then the first thing that we're going to do, if you come to the end there, you just add a plus and come to under the selecting a colorblind safe palette, I don't know how to say this. So let's use, this is one is coming from the package Virides. So that's the one that we installed above. So to change that, you know, we probably played around with this on our first ggplot class. We're going to do scale, because we're changing the fill, we're going to say scale underscore fill underscore, and then there's a whole bunch of options. I want to do Virides B for bind. So it's creating bins of colors, even though production is a continuous variable, it's going to create bins for us. And inside of this function here, it has different so there's an argument called option, which is basically what Virides color scale you want. I want the one called C. So this is, I think, is the same as Magma. If you ever worked with 3D scales, if you have not, you can just forget about it. But if you run it, it's basically going to use a colorblind safe color scale or fill scale for us, right? So basically just change that. Now, the next thing I want to do here is don't forget to add a plus after that, come to the next line. I want to change the fill legend and give the plot a title. So right now the fill legend is prod me view because that's the name of the column, right? So if you recall, we used the labs function before to change labels around. So here, because the prod mu is being mapped to fill, we're gonna use the fill argument and say fill equals open and close quotation marks, can say production open and close parentheses, million bushels, like that. So first thing was that if you just run that, this is how it looks like. Let me read that again. This is how it looks like. There's a neat trick I want to show you here that, so production million bushels all in the same line. It made the legend kind of long. And we can fix that. We can break line between production and million bushels. To do that in code, we basically come here and add a /n for new line. So if you run this, it basically breaks line where you added the /n. So next thing that we wanted to do here, so we changed the fill label. Now let's give it a title. So it's still inside the labs function. So right after you close the parentheses for the fill, you can add a comma and hit return just to break the code. And let's say it has an argument called title. So title equals open and close quotation marks. I want to call this county level soybeans production in 2021. Right, so if we run that, we have a title now in our plot, which is something that someone mentioned earlier about making it more looking nicer. So that's definitely one thing that we can do. Okay, so that was it, at least with changing the labels. Now, let's say I wanted to add in this plot the labels of the county. So I want to have each county with their name inside of the county boundary. So after the labs, add a plus, come under the adding county names. There's another geom sf function we can use that's called geom underscore sf underscore text. So it's again to give labels when your object is an SF object. So this is what we're going to do. So we have to specify the data. Since we started all this with a pipe workflow and this is the data coming in, to make sure that R understands that's what we want to use, we can use this tilde dot notation, which basically means whichever data is coming through the pipe, which is that is what should be considered at this stage. So that's what we're doing. We add a comma. I just want to break the code to make it easier to see. And we're gonna call the aesthetics function. And now, because this is a geomsf text, it has an argument inside of AS that is called label. So we say label equals then the name of the column that has the county names, which is called county. I just well, we can just run up until this point so we can see what happens. Okay, so we see that the labels are there now, but they're kind of big, right? So let's just fix that. Does anyone have a question? Oh. Oh.
Sorry.
Oh, no worries. All right. So to fix that, what we're going to do is come back here on the geomsf text. I want to add a comma, and we're going to change the size of that label or that text. Let's say size equals 2. And I also want to change the color to be one color, all of them. So we can add another comma and say color equals white. I want to have it as a white color. Okay, so if we run that, this is what we are ending up with. Let me just show you the code again and a little bit of the output so you can see what's going on. It is giving us a warning here, and that's completely fine. You can just ignore that. And now the last thing I want to do here is just change to a cleaner theme. So let's say I wanted a theme that didn't include the axis here, right? Because the axis, the X and Y axis are just coordinates in WGS, so in degrees. If I just want to remove them, let's come here at a plus, and there is come after the changing to a cleaner theme comment, and there is a theme called theme underscore void, which is a very clean theme. So if we run that, this is what we end up with. Okay, so this is looking a lot better, I feel. So now what we can also do is save this plot to file, right? So let's use the ggsave function, open and close quotation marks. We need to get outside of the code folder. Let's go inside of the output folder, since this is an output that we're creating. And let's call this soy-prod-21.png. So this is how I want to call it. If you run that, and then you come here on the right side, you click on the R blue button to take you to the home of the project, go on output, and then just open that. It should open for you this, right? Which is pretty cool. It's a pretty neat map. We have production, we have the name of the counties that reported production, we have a title, everything is looking pretty neat. All right, was everyone able to make it to this? I mean, was someone not able to make it to this point that will like some help?
Yeah, but maybe later because like I missed that somewhere.
Okay, well, we can definitely connect later. Yeah, just send me an email and we'll do that. Okay, so this was a, excuse me. This was a static map, which is already looking pretty nice. But I do want to take the chance here to show you a couple of different ways we can make this map interactive, which I think, especially working with geospatial data, can be very nice to have those types of outputs. So the first thing that I want to do with you here is create a animated map. So I left you, I think, most of the code. There are only a few things that we need to change here. So the first thing to do an animated, so what I want to do, let me first give you the vision of what I want to do, and then we're going to go about the code of that. So what I want to do with this animated map is create a GIF or GIF, depending how that's pronounced, where each year is a different map, right? So for each year, there's going to be like 2021, 2020, 2019, just appearing consecutively after the other, kind of as a GIF, right? So that is my goal for this next part that I want to show you. If you can picture that in your head. So the thing is, for us to do that, we have to save our plot to an object and then animate that object. I'm basically leaving you most of the code already. So we're going to save this to map.ts, and the different versions or the different maps are going to be appearing on top of each other is going to be over different years. So each year is going to have a map, but it's going to be appearing one after the other in the sequence that makes sense. So the first thing that I left you for us to do here, so we're starting with SoySP, so the spatial that has production million bushels, filtering only the last 10 years, because if we do for all the data set is a lot of years, and it's just more difficult to see that animation in a way that makes sense. So I'm keeping only the last 10 years for this. So you come here on the making year integer for title. We're going to work on this right now. That so what we're going to do is use a mutate function. So you already had the pipe up there. So just use the mutate. We're going to say year equals, there's a function called as.integer, and then inside of it, we just say year. This is just making, so up until this point, year was being interpreted as double. And what the difference between double and integer is that doubles can be can have a point something. It can be a fraction. Even though all of our years were full numbers, but because R was seeing them as integers, when we make the animated plot, it was saying like production in 2020.85, which makes no sense. So just to avoid that, when we get to that point, we're going to transform year to integer, so that doesn't happen. So it's a full integer value. You can just go ahead and add a pipe there. I left you most of the code, so we're starting at ggplot using geom.sf, just as we did above with the Georgia County W. So again, this is just adding all the Georgia counties shapefile or vector files. Then we're adding the geom.sf to bring production. One trick here, because we're going to do an animation, we have to, so we had 3 dots there. Please go ahead and delete those 3 dots. This is just a placeholder. For those animations to look nice, we have to create a grouping inside of this geom.sf. So to do that, it has an argument called group. We're going to say group equals, and then there's a function called interaction. We're going to use that function interaction, and we're going to give the function interaction production in million bushels, comma, year. So we're basically creating an interaction between production and year. And again, this is just a specificity about animated plots in R. If you're not doing animated plots, at least you don't have to worry about this for right now. But since we are doing this exercise, I just wanted to do that already, and so you can see that. Okay, so feel free to actually copy this group equals interaction between production and year. Copy that, because we're also going to change that down here. So just walking you through again. So adding all Georgia counties, adding just the Georgia counties that have production reported for any given year. So not 2021, but any given year. Changing the scale to colorblind safe option C, as we did above. Changing the labs here of both the fill and the title, which also things we did above. So that's why we're not doing again. Adding the county names on the counties. So we did also above, but again, here on the ... just go ahead and delete that and paste what you copied from above. So the group equals interaction between production and year. And then we're finally adding a theme, right? So notice that right now, even though we are filtering data, but on the plot, on the static plot above, we've filtered to have only 1 year of data. That was 2021. Now we're having 10 years of data. That is everything from 2011 and on. So 2011 to 2021. So if you run this, it should work all right. If you did the group interactions in the right place, you remove the ... it should have worked fine. For you, so we did all that and saved that into this object called map.ts. I'm just gonna print map.ts below. Oh, maybe that was not a good idea because there's a whole bunch of stuff. Yeah. Okay, so don't do that. Don't print map.ts because it's just a lot of stuff. Imagine it's multiple plots for each one of the 10 years. Anyone has a question? Okay, maybe not. So now let's basically, now that we created this plot which has all years, let's animate by year. So you come down down here, where first thing you're going to do is call the object that we saved, the animated map. So that's map.ts. We add a plus. So not pipe, add a plus, hit return. And there's this function called transition underscore time that comes from the GG anime package that we installed in the beginning. And we're going to say here we need to give the column that we want to animate over. So that's year, right? So we say that, and well, you don't run on your side yet. I'm going to run on mine because I think it's going to be a little bit faster, just so you see what happens when we do this. It's going to, take a moment just to create that animation. And it created here on the side. Let me pop that out so you can see. So you see that, so the counties that have reported production and whatever their production was for a given year, they're changing over time. But notice that county level soybeans production in 2021 is the title. What I want to do is to have each plot, so the year 2021 is not changing in this title, is staying the same. And that's not right because this data is coming from different years that I don't even know what it is if I'm just looking at the animated plot, because it's not changing, right? So how can we actually change and make that 2021 change according to the year that's being shown in this animated map? So let's just close this. Let me come back to my R Studio and let me close this as well so it doesn't keep blinking there. So we're going to come here after the transition time, add a plus, and we're going to use the labs function again. We're going to say, we're going to change the title argument. So we can open and close quotation marks. I want to say county level soybeans production in. So before we said in 2021, right? But if I want this number 2021 to change according to the year that's being shown on that animated graph, the GG animate package has a way to do that, which is open and close curly brackets, and inside of the curly brackets say frame underscore time, like that. So this frame underscore time is actually a variable that is created by GG animate. When we say transition time, it creates that based on the variable that we give it, and then it basically knows which variable should be changing for each map. So at this point, if I just go ahead and run it, if you want to try to run on your side, you feel free to do as well. It should work. It may take a moment here for that to get going, but it should work. And when it creates on the side, you can just click on that pop out. So now notice that the year is changing according to the data that's being shown. And because we filter from 2011 on, that's what is just showing 2011 on.
Dr. Bastos, here at Athens, we are getting an error. It's saying warning state point on surface, lot of warnings.
Something like this?
Yes.
Yeah, so this is just a warning, but it just means that it is working. And we really don't have to worry about it. It's just because it is SF, it's just saying that it's just a warning that SF gives, but it should still work.
You have to press mute.
I'm getting an error. It says the the transform package required to train SF layer.
Yeah, so that package is the one that we installed in the beginning. This one right here, transformer. If you, so that package is needed to animate an SF object. So if you didn't install it, you can go ahead and do that. I don't think we have to load it, but you know, if it's still not working, the animation, you can try to load it as well. Okay, so you know, I just wanted to show this trick here for animating a plot. In this case, the production of soybeans in the last 10 years in Georgia. I think that's a pretty cool visualization. And we have a few minutes here. I want to try, let's see. Yeah, I think we can finish up. We can get to the end of today in the next few minutes. So let's just keep going. And if anyone has had issues creating the animation, let me know. I can help you out later. But I just want to show you another way of bringing interactivity to a map in R. So I want to create an interactive map of the most recent year. So to do that, I already left you a little bit of the code. We're basically creating a new object called soysp21 because we're filtering only 2021 to show. So we can go ahead and run that. And now we're going to use the function mapView, which comes from the same package name, mapView. So we're going to say soy_sp_21. If you just run that, that should create this map for you right below. It is an interactive map, so you can zoom in, zoom out, you can click on the different counties. At this point, it's not very useful yet, right? So one thing that we want to do is come back on the map view, add a comma, hit return, and the syntax of max view is not like ggplot. So we're going to be doing some things that we did in ggplot, but the arguments will be different. So it has an argument called zcol to color your polygons according to a z variable. So we just have to say zcol equals open and close parentheses prod million bushels. So if you run it again, you see that it created a legend for us. Now each county is colored according to their production. And if you hover on top of them, you see what the actual production was for that year. So again, this is 2021 only. Another thing I want to change here is that you can see that the counties have, like the counties fill has some transparency. I want to make them not transparent. So we add a comma, hit return, and we say alpha dot regions equals 1. So alpha is transparency and it ranges from 0 to 1. So 0 would be fully transparent, 1 would be solid. So if we do that, now our counties are not transparent anymore. And also, I just want to change the color scheme here to match the one that we were using on the static plot. So if you remember on static plot, we were using Virides, but a different option C. So here we don't have an option C to do, but it has this argument called col.regions that we can give any color scheme here. On the Virides package, there is a column called plasma that creates a color scheme based on the plasma palette, I guess. And we just give here the number of colors we want from that palette. I want to have 20 in this case. Oh, and I forgot a comma after the 1, so I'm going to add that. So if we run this, this is what we end up with. So a very similar color scheme as what we use on the static map on the option C on the scale fill Virides. And really the last thing that we have here that I'm missing is just that I wanted to see all the counties and not just the ones that have reported data in 2021. So to do that, we can actually come back here on the map view. I just want to give a few returns and we can add another map view that has to come first. So we can just go ahead and type map view, and that one would be the Georgia County W, which again is the object that has all counties. And now similarly to ggplot, if we just add a plus, it connects both. So that's what gives us. The only problem is that it's trying to give a color to different counties at the Georgia County level. And I don't want that to happen because otherwise our data gets messy with, the color of different counties that is coming from just all counties. So to change that, we can come here, add a comma. We can change again the col.regions argument and say equals to white. So with just one color for all of them. Let's try that and see what happens. So it did do what we wanted, but I still seeing like this legend here, all the counties appearing there, which is not very useful. So I want to come here on top and say add a comma, hit return, and say legend equals null, and null has to be all uppercase. So if we run that now, we'd see that now counties are not appearing anymore in the legend. So that's what I wanted. But notice how the map type changed as well to a black type of map type. And just, I want to change that back to the map type we had originally, which was looking like this, like white. So to do that, we can come back here on the first map view on Georgia County W, add a comma, and there is a argument called map.types. So in plural, map.types. And it has an option, so open and close parentheses, it has an option called Carto with C uppercase, DB, so DB also uppercase, dot positron with P uppercase, like this. It's kind of a funny name, it doesn't, at least to me, is not very intuitive, but that's the map type that we get with all the white in the background. So carto db.positron. So if we run this, then we end up with the map that we wanted. So the background of all the states is white. The counties in Georgia are also white, and colored are only the ones that had data in 2021. And here's the legend. So what I want to show you now is, just 2 more minutes and we're going to wrap up here. Sorry that we're already after 10:10 or 11:10. But if I come here and render, you don't have to do this yet because it will take some time on your side. But I just want to show you how cool this is. It's like when we render this, this type of file, again, it's a Quarto file. So it's going to create an HTML with everything we did on this file. And it does take a little bit of time to create that animation. So that's why it's kind of stopped at 86% here on the progress of creating it. But it will create that in a second here. And I just want to pop that out so we can see what's going on. So, we have, again, like all the heading, titles, or subtitle, authors, and then we have the headings, again, as before. We do have the code as well folded. We have the outputs. We do have all the maps that we created already showing up there. We have our static map. We have our publication ready static map. We have our interactive map appearing here as well in this HTML, which I think is pretty cool. And then we also have the interactive map on this HTML here, right? So again, you can zoom in, zoom out. You can see what was the production by county at this year and so on. So it's really a very cool way to creating visualizations of data, especially geospatial data, where you do, we didn't have to do animated maps or interactive maps, but I think since we have the power of creating an HTML out of it, just makes it very powerful. All right, so I think that's all I had for today. We can talk about the mini project on Friday, which is basically going to be, I will ask you, each one of you, to download a different data set from NASS, and you're basically going to have to answer some questions that I send you, that I have in the assignment or in the project, all related to things that we did in this 2 last scripts. So all the way from tables, plots, maps, interactive maps, for a different data set altogether. Okay, that's all I had today. Anyone has any questions that can be addressed now?
Go back to the future.
again, clear that. If you had any issues with, packages or creating the interactive or the creating the interactive maps, rendering the Quartil files, send me an email and I will help you out with that. You're gonna need that for the projects. So thanks everyone. See you Friday.